Our first segment today is a total disaster. That isn't a diss. We sent Erica to a lab where they study natural disasters. Check it out.
Natural disasters are on the rise, and if we want to keep our homes standing tall, we're going to need some backup. That's why scientists here in the disaster lab at UC Berkeley are hard at work. They study small-scale disasters in order to develop big solutions that can keep us safe. Like physics student Kaavya Kochar, who studies how fire impacts the materials we use to build homes.
Since I've been a kid, I've just been so inquisitive about how things work.
I am Kaavya, and today we're going to calculate the value of gravity.
Just having that bug in my mind to have an answer to everything, like why does it work like that? Why is this thing the way it is? And I think that's just what drove me to science, because I just wanted answers so badly.
Hi, Kaavya. Hi. So nice to finally meet you.
Hi, nice to meet you. How are you?
I'm good. This place is so cool. Can you tell me a little bit about the disaster lab?
What we try to do is we bring great ideas and innovation and technology to the real world. Testing materials that make structures more resilient to it. Anything you could think of, like wildfires, flooding, oil spills, earthquakes.
So what are we going to start with today?
We're going to be testing a bunch of materials for fire resilience.
Show me the way. I'm so excited.
All right, let's go.
Okay.
Kaavya introduces me to firefighter trainee Anai, who not only works with the lab collecting data on actual fires, she's also going to help oversee our flame-based testing.
What we're going to see now are two different types of paint. This is just regular paint on houses, and that is a special type of paint we've been working on. That's an intumescent paint.
Intumescent paints contain ingredients like graphite that expand when exposed to fire, creating a protective barrier over whatever it's covering.
What we're working on today is that we're going to see how you can protect the exterior of a house from impacts of a wildfire.
We'll be doing a little experiment, putting a few birdhouses under the heat to see if this fire-resistant paint really holds up. But I should probably learn how to use a blowtorch.
Woo!
3, 2, 1, go.
This is so cool. Or should I say really hot? This is crazy. I cannot believe how different these look.
What we have here is just regular paint. It would burn as you would expect it to burn. All this black stuff that has come up here protects whatever's inside.
So you ready to scrape?
Let's do it.
Okay. This is insane. It's intact.
Yeah, and you could see when I was scraping, we had chunks of the wood falling out with the ashes.
Now imagine if it was like a real big house with like actual flames. Like this would probably be destroyed. And then this would be still standing with the siding intact.
You can see how just something like a layer of paint in your exterior can do so much in protecting the people, the house, the community.
Kaavya tells me wood isn't the only material that needs to be protected from a wildfire. Even something as hard as a home's concrete foundation can be pushed to its structural limit from exposure to flame's extreme heat, followed by rapid cooling from fire-quenching water.
So the very thing that, in theory, helps put out fires can also cause a lot of problems because of the way that concrete reacts to heat.
Yeah, and how suddenly the temperature changes that it leads to fractures and faults.
So, we toast up a cement cylinder.
We have our kiln right here, and it's set to about 1,000 degrees Celsius, which is roughly the same temperature that it would be exposed to in the case of a wildfire.
Woo! That's definitely got a temperature. 840 degrees Celsius. Okay.
Okay, let's go.
You think you've seen it all, and then you see a piece of concrete make its own jacuzzi because it's 840 degrees Celsius, and it's falling apart.
Once it's cooled enough to touch, Kaavya shows me how fragile this temperature-shocked foundation is.
Oh,
There we go.
Who knew that putting hot concrete in water would make it crumble like dunking a cookie in milk? Luckily, the scientists here at the Disaster Lab are on the job.
I can obviously see how the heat can affect the structure and foundation of your house. What are the kinds of things that you use this information for?
Well, one of the things that we can do, because concrete is made up of a mixture of a bunch of things, we can tweak around and see what we can do to make it more heat resilient.
So what do you say we do something a little more relaxing? Like, I have a wall in my apartment that needs painting, so maybe you could bring the intumescent paint and I'll just bring some cookies.
Have you ever painted a wall before?
No.
Yeah, I think we've had enough disasters for one day.
Yeah, no fair, yeah.
If you're watching this, you must have really liked the video. Make sure you follow and subscribe, and check out these other videos that are even better. No, really. I've seen this one over 100 times.